Alright, so now that we created the JUnits for our service and our controller classes, how about we increment the complexity a little more. This time we will try to create run the automation for the service class, customer service IMPL type 2. Let's take a look at that class in our test project. Okay, so this is the class. If you see, compared to the earlier service class, this one has many methods here. You see this? A lot of methods, and all methods of different combination. There are at least more than 10 methods in here, if you see, and each of these methods are of different combination. For example, this one here is a method that does not take any arguments and has a return type which is of type list. It is also has a external class and method invocation. The second one here is a method which takes inputs, more than one inputs, and also has a return which is of primitive type and does not have anything that it invokes from the external class. The third one here again is another variation. This again takes inputs, and it takes a character, it takes a object, it takes a Java type as the return type. So same way, if you see, there are many combinations that are put in here, and typically these are the combinations that you would normally find in your regular day-to-day programming, and we want to see, when you run automation against this, what kind of output does it generate. For example, this one here, this particular method here is of the pattern where it takes an input which is of type object, not a primitive, it's type of an object, and returns a void. So when you run JUnit, when you create JUnits, if the method does not return a certain type, then there is a certain different way in which the mocking, the verifications need to be done, compared to a method like this, where you need to verify the object that got returned from this. For example, here when we verify the actual and expected output of this method, and this is a customer object, we could say that, okay, does this customer object, is this of type customer, is this of an instance customer, does this object have inside it a value like customer number, and is that customer number of so and so value. But when it is a void, we cannot really say is this of type void. There is no instance type void. We cannot also go ahead and check the elements of this void, because it is a void, does not have any elements in it. Instead the approach to verify these kind of methods is different. We use something called do nothing. So in our automation, we will see how our automation generates the output based on the scenarios, if it based on the scenarios that it encounters. So let's get started. So again, we go back to our our steps, demonstration steps, and then we are going to be generating it for this one here, this method. So again, we go back to our application, the location where our setup.bat is located. So here, just launch it. So these steps, you're already familiar with this. We will move forward. Where is your application located? It is located here. We've already done this before. Where is your location of your application main class? It is here. We already know this. Okay, I want to auto generate the JUnits, so I'm going to do a 1. Move forward. All right, what is please provide the fully qualified name of the target class you want to. The target class that we want to run is this one here. We will take the entire package first, and then we will take the name of the class, and we will say go. So okay, and just keep moving forward. We just want to, it's going to do the necessary adjustments with the directories. All right, these are all familiar steps from our last runs. Here it is going to basically gather all the information that it needs on the details of the specifications of Maven, Spring Boot, etc., etc. So we will allow it to move forward. Okay, it has gathered all the information, and now it will attempt to generate the automation steps required for JUnit creation. Okay, so now like we see in the earlier runs also, it wants to confirm whether the type that we want to generate the JUnits for is a service. Yes, it's a service because it has a service here, and it has based on this it has detected that it's a service type of class. So now it knows what is the pattern to be followed to generate the JUnits. All right, so what does it need now? Okay, it is saying it has found this piece of code here, and it is saying the stub has a return type of optional. What is the parameterized type inside this? So let's go to our class and see. Okay, we got it here, and it is saying has a return type of optional parameterized. What is this parameterized? What is inside this? Okay, inside this output return type, it's customer, and we already know that customer is, so we just have to provide it the fully qualified path of this particular POJO. It's a return type that it's looking for, this method. So we give that, and then it moves forward. Okay, now it is saying that there is a delete that gets called with the parameter cust. What is the data type of the input argument? This cust is an input argument. What is the data type of the input argument in the above external class method invocation? So we go back to our class and we try to find where this is. This is customer, we don't need this. Let's close these other items. Sure. Yeah, so you see this. What is the input type inside this delete? That's what it wants to know, and it is actually customer. So it's the same customer, com bank next customer management. So it's the same one that we earlier provided. So we're going to give it the same input. Okay. Again, it has found something called delete by ID, and it wants to know what is the data type of the input argument in the external class method invocation. If empty, enter void. Okay, so delete by ID has an input of 2. 2 is an integer, so we are going to give it an int here. All right, it is also detected list. Is the above class or POJO specific to your application, not internal to your Java or Spring? So basically what it wants to know is it has found list. At times it's not able to figure out what is list. Is it like our own custom object that we created like customer, or is it something that is the predefined Java type object? List is actually a Java type object. It's a standard Java util list. So it wants to know whether it's our custom application, like a custom POJO inside our application, or it's one of those that is internal to Java or Spring. Yeah, in our case, in this case, it is not internal. It is not specific to our application. Enter Y to confirm else. So since it is not a POJO of our application, we will enter N and we move forward. Okay. Okay, now here it is basically still trying to deduce multiple other things, and if it finds certain responses of yours matching to the questions it has, then it will simply use those cached responses. Here again it needs to know it has found this particular this particular line, and what does it want to know now? What is the return type of this above method? What is the return type? The return type of this is customer. Again, it's the same customer Pojo that we looked at. So we are going to give it the same customer Pojo as input. Okay. The question it has, okay, it asked a question, it got a response from you earlier, got the answer from your earlier responses. Again, it got asked the questions and it is getting answers from your earlier responses. So that's why it doesn't keep bothering you with the same type of questions, same questions, same identical questions. It just deduces from its previous from your previous responses. Okay, it still needs some more information. Get customer by ID, optional. So it has found this line here. All right, what is the number of input arguments in the external class method invocation? What is the number of input arguments? So external class, so we are the one that we are running our JUnits for is a service. The external classes that our service uses is either some kind of handler classes or repositories. So we know that. So this is a repository and this is the method of the repository getting called. So it wants to know what is the number of input arguments. Here it is, see, it's just one. At times what happens is figuring out this kind of lexical structures becomes quite cumbersome for processing, and that's why, but for us, as when we look at it, it's extremely easy to figure out that it's only one. The pattern matching could be very cumbersome, and hence it is just a practical and a better way just to ask the question rather than trying to figure out all those details in there. Each programmer has a different way of writing the code, and all the styles that are written are legal. Hence we cannot really restrict, or we cannot say that automation will run for only certain type of coding style. Hence this particular approach is taken to make it more flexible. Here, instead of trying to determine and most likely going wrong with the analysis, our automation asks the question so that it can get a confirmation from you. So here it needs to know what is the number of input arguments in this external class method invocation. So the external class is this, method invocation is this, and the number of input arguments is this. That means it is 1. So we will just provide it that input 1. Okay, the next question is again for customer repo find by ID. This stub has a return type of optional parameterized. Again, it wants to know what that data type is inside this parameterized. So let's just, and it's a return type. So let's just go back here to our target class and find this return type of find by ID. Return type of find by ID is optional, and inside that is customer. It is looking for this parameterized type. It is already determined that it's an optional, but it needs to know what is inside this parameterized. Again, figuring these things out through lexical analysis becomes quite cumbersome. Hence it's just way easier to ask the user to provide this particular input, and it's a very basic and easy input for the user to just look and provide. And especially if you are the author of this particular class, of this target class, or you are familiar with this code, then you will be absolutely easily be able to identify this and provide the input. So again, here we know that we're looking for find by ID customer, get customer number of arguments, find by ID, get customer. This one is what we're looking for. The number of input is 1, so we will provide it. Oh, I'm sorry, it's looking for the return type. It is the return type in optional, parameterized, and inside find by ID customer, get customer. Okay. Return type is customer for it. All right, and you can see it here also, optional customer. So we will provide it the same input that we provided earlier. Okay, that's it. With this 5 very basic questions, it has generated the JUnits for you. So now it's saying just close this console and go to the main parent console, where you can proceed with your next steps in the automation. So we exit this, go back to our main console, and here it says once the code processing, that means the processing that we just finished was launched in a new window. Once it completes, press any key to proceed. So we will press a key and move forward. And here says your auto-generated JUnits are located at this location. Please review those JUnits. So just like last time, we will go and verify what got created for us. Okay, and let's do this. And the most recent JUnits that got created are these ones here. So we will now check what is the status on this. There are times when the JUnits that it generates could have compilation error, minor compilation error, which need tweaking and correction from you. So it's better to just look at, verify it, and see whether if there are any compilation errors in that. So this is the class that it actually generated, customer service IMPL type 2 test, and that is a test for this particular target method. Now if you see how many, there are so many methods that this particular service class has, and here you go here and you see it has generated all these test methods for it. For every method in that, every public method in that service class, it has generated a corresponding test method. Okay, and it has done it based on the scenarios. For example, let's say this one here, it's an update customer. For update customer, what do we verify? We verify that the result that comes through is of instance type customer. Let's take an example where it was a void. Okay, so this particular case, in this particular case our return type was void. So but there was an invocation to an external class that was done. So the JUnit that it generated has do nothing for the mocking, for the stubbing, because there is no return type from that particular call. Whereas here, when in the verification part, because we are not getting anything from that invocation, the return type of this method is void. We cannot really assert anything, assert that this value equal to that value. The only assertion or verification that we can do is this, that is we want to verify that when this particular invocation was made, when this particular service method invocation was made, the customer report delete was actually called, and it was called only once. So that's what is being done. So all these JUnits are generated based on the specific scenarios, depending on what that particular method intends to do. Alright, so now we will execute this JUnit. For that we say launch auto generated JUnits. Yes, we want to see whether the JUnit that we actually generated is a legal and working one. Legal, yes, because it has no compilation errors, and it has all the three components that a JUnit requires. But does it run? Let's check. Tests run 19. There were 19 methods inside the service for which the JUnits were created, and all have been run and all have been successful. There was not a single failure. Now this is the Jacoco report that it generated, and we see in the earlier case we had 10%, and now our coverage has increased to 25%. Now let's go to the specific service class and see. Our class was customer service IMPL 2. See this? We have 96% coverage of this of this particular complex service method, which had 19 methods in it, all of different type, all of different scenarios, and we got a very high 96% coverage. That is indeed awesome, and that too without writing a single line of code.